So bear with me. This is actually a very cool thing. We're going to derive something that somebody got a Nobel Prize for. Okay? So remember that if this thing's sitting still, of course, the light just goes up and it goes back. And the time it takes, and this is called the proper time, okay, is, and we use the T naught, that's our proper time, right? It's just twice that distance. And the distance is d, right? So 2d over the speed of light, c, right? This is distance divided by time. It's got to go there and back, so it's twice d, and then we divide by c, right? But because it's following this path here, and because the ship is moving at some velocity v this way, right? Okay, it has to follow this path, and it takes longer to take, right? So that time is, and this is called the dilated time, right, is twice this path with that hypotenuse, right? So we can use the Pythagorean theorem, and it's d squared plus L squared, right? And then that is divided by the speed of light, right? And then we can further substitute in here, right? Because we know that this distance it travels here, from here to here, is just the velocity times the time. Right, whatever this ship is going times the time, and this would be, of course, the dilated time. And so L is therefore, L is what is Vt over 2, right? It's half that distance, right? Because this is what we're calling L is this, right? Okay, so 2L is equal to Vt, so L is Vt over 2. So I can substitute that in, so that's my next step, right? So let's substitute that in. Okay, so T is equal to 2 times, got to be a radical here. I'm always trying to be a radical. Okay, so then d squared, right, plus, and then we've got this thing here, the Vt over 2 squared, right? Vt over 2 squared, right? And then that's over c, right? And now we've got it. This is it, right? We've got the whole thing here. We're going to do some simplifying, obviously, and then, that's why we've got all this space here. And then the only problem is, too, also our formula for T has T in it, which is sort of a thing. We got to get all the T's on this side and see what doubles up, right? All right, so my next step is, I believe I'm going to square both sides. Shall we do that? Let's square both sides. So let's go T squared equals 4 times d squared plus v squared t squared over 4. I'm just sort of squaring that thing, right? And then this thing is, of course, squared, so it goes away, right? And then that's divided by c squared, right? Yeah? So all I did was I squared this thing, and then we squared this. So the radical actually goes away, right? We can get rid of that, right? We square that thing. I squared the t, I squared the 2 is 4, and then the squaring gets rid of the radical, right? So let's multiply across by c squared, right? And we get c squared t squared over, let's say, equals 4 times d squared plus v squared t squared over 4. All right. Let's just keep going here, man. We can do it. This dog's gonna hunt. Okay, here we go. Okay, so now my next thing is, I think what I want to do is distribute this side here. So we have c squared t squared equals, and we distribute this, right? We'll get 4d squared. And then when we multiply 4d squared times c squared t squared over 4, we just get v squared t squared, right? All right. We are getting so close. Let's see, what can we do here? Oh, we got to get the t squareds on the same side. So my next step is to subtract this term from both sides. So c squared t squared minus v squared t squared equals 4d squared. All right. Oh, we're getting so close here. All right, what do we want to do? Oh, factor out the t squared. So t squared outside of c squared minus v squared equals 4d squared. Let's divide both sides by c squared. That's cool, because see this term right here is actually the square of this one, so this is looking actually pretty good. You don't know that it looks good, but I know that it looks good. All right, so I'm going to rewrite this thing here. Okay, so I've got t squared here. Let's see here. All right, here we go. Okay, so I've got t squared, right, and then that's times, and then c squared over c squared is 1. And then v squared over c squared is v squared over c squared, right? Ooh, this is looking really good. Okay, equals 4d squared over c squared. And then, of course, the next thing to do is to solve it for t squared, right? So t squared is equal to, I can see this pen going slower and slower. The more things I draw, for some reason, this pen goes slower and slower. So I've got 4d squared over c squared over parentheses 1 minus v squared over c squared. All right. Oh, we are so close. Look at this. All I have to do is square root both sides. Right? If I square root both sides, I get t equals, well, the square root of that is just 2d over c. Right? And then the denominator just simply becomes a square root. This looks really familiar, doesn't it? 1 minus v squared over c squared, right? So let's write that up here. So this is it. So notice that this thing in the numerator is just t naught, right? So here it is. Let's write nice and big, right? So t is equal to the undilated time, the proper time, right? And then it's 1 minus v squared over c squared. Isn't that amazing? Now let me just say that deriving mass dilation, the famous part of this, of course, let's just say is beyond the scope of certainly my knowledge. But it's customary to say beyond the scope of a high school classroom. That imply that I actually know how to do it, but I don't. Okay, so anyway, there it is, right? So this is our dilated time, this, right? This is the proper time. So if the watch didn't move, this is how long it would take to tick, right? And then that's the speed you're traveling. That's the speed of light squared. That's our derivation.